How's it going, everyone? Welcome to another video on the enterprise UI development. Here, Euler again. This is a course taught by Steve Kinney, where now the entire goal of this is to understand that for lead UI specialists, which is eventually something that you perhaps going to look at it and to face that. At each one of these phases, as a junior, you face some sort of challenge, as well as the senior, and now as a UI, as a lead UI developers, we need to actually find a way that not only that we're capable to build things or to fix things or to provide value to the business, but also how you can maintain that value. Specifically, how you can maintain is code bases over a long period of time with a wide range of contributors in large teams. So here we're gonna see is the fundamentals, as well as how we can set up the infrastructure needed to maintain that code with a wide range of collaborators in large teams. And first thing first, we need to understand is what a couple things, like how do we get here, okay, and why do we need to build this infrastructure as a way to make this code maintainable. Because especially you're going to, if you inherit something, right, similar like you inherit is an old bike, an old microwave, or an old cell phone, right? A lot of the time you want to find a way to make that maintainable, right? To keep, to survive, to strive, and or to sustain with you. So in the context of software, a lot of the time we receive is software that come from older code bases, okay, that we also need to maintain. This is true for a lot of large code bases out there, and a lot of company actually that are doing that. Perhaps you want to now, or the PM, okay, they want to change now the directions of the product. All right, so the CEO say, hey, you know what, we would like to actually is that you are that particular POC that you build as a way to see if that is feasible to integrate in our app. Well, now that'll be a feature. Ship that to production, you know. Or perhaps you want to migrate from older frameworks, especially JavaScript, which is something true, unfortunately, or like it or not, to whatever hot is these days, and or okay, you want to start a new project with the right foot. So there's a couple of things, especially that we need to clarify. And one of them is, now that we know what is the problem that we're trying to solve by looking at this enterprise UI development, okay, we want to know is now what are the industry practice, right? Here we're gonna cover things like unit testing, component testing, integration testing, or browser integration testing with playwrights, as well as how and when not to fake stuff for testing, set up the infrastructures, and enforcing. And the infrastructure here is, well, what is the structure of your components, and enforcing coding standards that are now allow us to build a CI pipeline. These specific things, it is based on the question of what is enterprise UI, okay? Well, what is the problem that enterprise UI, as I mentioned early in this video, and not only that, is like some core questions like how do we create maintainable code, and how do we maintain maintainable code, what maintainability means, in terms of durability and adaptability. So how can we now create is a code that when a lot of people actually add in, when we want to change something, not only add new features but also change, modify something, we can do that with with high confidence that we didn't break anything. That's one, right? And also we want is to know is how can we make that happen for updating our dependencies or for doing a refactoring without fear. And here we're gonna say is what are the things needed to actually work towards that goal. And that is, well, that you need to define what is the end goal and the systems that allow you to now move towards that. So I think that's something quite interesting here, because, well, he mentioned is not only is the components of a well-architectured UI from Amazon as well. So you have now the testing, the statistic analysis, build process, separation of concern, all of this kind of thing. But what really is relevant for what make a project or something that is sustainable, because at the end of the day, this is something that you can replicate to other stuff. Okay, so how you can now is make something that is maintainable, or you can maintain something. It is durability and it is adaptability. So you need a system or a set of systems that allows you to move towards that goal. So in the context of code, pretty much, for example, if you have a motorcycle, and I wish you all to have a motorcycle soon in your life, and if you do, great. And if you have, and if you're bored to have a lot of motorcycle, that's also great. But the idea here is that find those systems that allow, or that find those what are the things that you need to do that allow you to now define is the know-how. And any time you encounter is a particularly pattern or a repeated things, a recurring things that happens, you develop now a process or a know-how, okay, that you can add to this system, that you can add to what is the goal of doing this. So perhaps it's quite too abstract. Of course, it's like, what in the F is this? Okay, shut up, man. Please show me something more straightforward. So we all know that we need to actually do some maintenance to our motorcycles. Fridge, the oven, the stove, or laptops. I don't think actually people do that, but it's important to you. For or data, all right. And for this context, I'm going to talk about is what are the things that you can do for maintaining your motorcycle, for example. Okay, so, well, that you recurrently need to send that to a technicians or to any mechanical, okay, that allows them to, you delegate that test to them, so you trust them in their processes, okay. And that's why it is important to make a quick pause here. That's one of the realizations, especially when you delegate things, that it is for both party. It is in its best interest to be a professional in whatever you do. You know what I mean? Because now people not only will recognize you that, hey, yes, you are the kind of guy or gal that we need to do this, right? And this is something that, well, the economy is stimulated. The specialization is needed. Again, you need to find the right balance here between that specialization, because what happened is that you can be so specialized in a particular area that is not in demand on the market. You know what I mean? So again, find here the sweet spot on that. But in any case, so here this is now the ingredients needed to make things sustainable, maintainable, durable, and adaptable. So you define the systems to answer what it does. Okay, what is the goal here? Maintainability. Okay, uh, and then you say, all right. So what are, in this particular case for on the code is like, well, what are the systems that allows to make that happen? To our code be sustainable. So far is, well, the testing infrastructure, the static analysis, and the build process, right? Because we want us to now make sure that this particular code work as expected. And by doing some of these particular tests, we actually verify that that happened. How can we do that? That's when we define is now processes. So, for example, like code review, which is something that is quite lengthy, verbose. Is also is essentially one of the bottleneck here. So depend on the particularly depend on the particular application that you develop. You might want to have that kind of thing. Let's say you want to develop an application in finance or hardware or in the medical industry. Okay, pharmaceutical. Of course, you really want to have a code review, a code peer review, right? And also, you want to now document that. You want to have these design documents and blueprints. So for any patterns that can arise, okay. So once you know how to do the things, there are certain patterns that arise. There are certain repetitive things that occur, and that's why we apply this thing for these common scenarios. That's why we have this pattern, this design pattern. It's like common problems or common solutions to common problems. Architecture. Hey, is this one, right? So the architecture. Hey, the state management. Is this one. Redux. Hey, the abstractions. And I think this is something quite interesting. Remember, as a way of how you can apply that to your life. Okay? So, for example, let's say you want to maintain your body, so you're going to define a system that, or several systems that allow you to do it. So systems like nutrition, budget, physical exercise, right? Sleep habits, which is something that I lack of. I have 3 or 4 of them. Good. And then you're going to define now the process is like, hey, in the nutrition is like, what are the food that I need to eat, right? In the budget is like, how much money do I need to sustain this, and now how. So things started to make much more tangible as you do this. Hey, what are the things that I need to or what are the exercise that I need to do as a way to keep it up, okay? And what are the things that I need, or what are the know-how, the process that I need when it comes to sleep, all right? So far so good. And then when you find recurring problems there, okay, you're not going to put is some patterns. So you identify in each one of those processes particularly patterns for that. So hey, patterns like I need to, in the case of nutrition, I need to actually is find the necessary nutrients for that, okay. And what are the practical things that I can do? Well, You define specific your nutrition that, because you have a goal. Similar for the budget. Hey, well, and now I know what are the things that I need to generate this budget. I'm going to apply that and going to invest and allocate that into that, and they're gonna do that weekly and monthly and that kind of thing. Similar for the aspect. But again, the idea here is to see now the relationship and then act accordingly. And how powerful is systems as a way to get you a desired outcome. That's another reason why I actually is recording this series of videos, because the end goal here is to be able to describe is all of this. So be able so improve my be good at what I'm doing, especially as a UI specialist, right? No redundant intent. So being good at what I'm doing, which is UI specialist, all right? Being good enough or very good at what I'm doing, all right? So this is the system that I define as a way to improve that. So I have my recording sessions and note taking systems and time management, right? So doing these kind of things and now the know-how is like, what, how are you going to do that kind of thing? What is the process of doing that kind of thing? It's like, well, for the video recording, I know what is the set of tool that I need to actually do that. And for the note taking is like, I know what are the things that are gonna take, that are gonna do, that are gonna transcribe that, and the sources that I need to. And the recording, the note taking, the note taking, and I mentioned another one, and the time management. Okay, this is also something I need to. Let me define this. It's like for that goal, man. This will be is okay. 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 System. Process, system and process, which is the end goal of this, top priority system and be good at UI specialist. Be good as a UI specialist, right? That's pretty much this. and the process is to recording. So this is the goal, right? This is the goal. The goal of this system, because if the system doesn't have any goal, it's mindlessly doing the thing that it is, right? Goal is that be good at UI specialist, because after all, that's specialist, right? Be good as a UI specialist. So what are the systems? Well, we have is now to achieve that goal is recording. Okay, recording. Note notes taken, as well as recording, notes taking, as well as time management. And the process will be is well, tools to use. The process, the know-how is, well, in this case is OBS, right? OBS. So the process is recording with OBS. Yeah, that's right. Recording with OBS. Takes note from, exactly, it's like notes taken from front end master, right? Not only that, is recording with OBS, notes taken from front end masters. Okay, note taking from front end masters, and schedule season, right? That's pretty much this. How long does it take? As long as as human possible it can be, right? Because then we will have another goal, and so on and so forth. And in this particular thing is something that is important. Recording with OBS, note taking from front end masters, and then schedule seasons, right? So we can finally is now upload recording to YouTube. Okay. Yeah, recording with OBS, note taking, schedule seasons, upload recording to YouTube. Yeah, that's right. Exactly. Upload recording to YouTube. Recording with OBS, note taking from front end master, schedule season, upload recording to YouTube. That's right. And then thumbnail creation. You know, there's several processes involved here. There's several processes involved here. Several processes involved here. And I fleshed that out, but it was by doing it. You know, I fleshed that out by doing it. So, in any case, yeah, so that's actually to understand what is the ingredients to make something maintainable, right? To make something maintainable. and what is the end goal of all of that. So because of that, right, since we are also describing a little bit of what infrastructure mean, which is the basics installations of, this is the basic installations in an to operate a systems for its economy, and that is for it is judicious use of resource, whether it's for households or firms. So this particular architecture, well architecture UI, as they mentioned now, which is the patterns involved there, is pretty much like that. So this is the things that we're going to see as a way to build now this particular infrastructure. So if we take a look at this, all right, first we're gonna see is now the, if you remember here, we're gonna see is the testing system or the testing infrastructure, okay, followed by the static analysis. So testing infrastructure, the static analysis and build systems. Again, this is very specific for this goal, which is the code, okay, and because of that, well, we started with the testing, right? So the idea here is that build now the so understand what the testing infrastructure is, as well as some common terminology or some jargon, mumbo jumbo that we need to know. After that, we are now able to write some tests, take a look at some advanced techniques for refactoring code, and then go into our first forays to set up a build systems with the aforementioned tests and make sure that everything works as expected. So that's great. That's interesting and powerful. Okay, but things first. First things first is this. So this is the spectrum, okay, of testing here. It's like, all right. So when you're going to write and develop this infrastructure, first we're going to take a look now at what is the spectrum of testing. So we have now the unit testing, because it's quite easy and straightforward to do that. We just only want to test is just that we actually expect that function do what it's supposed to do, and the end-to-end is that we expect now that that particular user flow works, and that it means that most of the time the application is now being clicked by a lot of users, especially hammering that in a hostile way. And this kind of test is actually quite expensive, because most of the time you don't own all of the other infrastructures along the way, and that's we have now this integration testing, which is, we're going to pretend that that is the E2E with using with that, which this integration testing is, well, the union of tests is one or more units, right? And we're gonna see how to do that, how that fit in our entire infrastructure, and the component testing, which is something recently new, as a way to test if this component actually behaves the way it is, pretty much, right? Similar with the unit testing, when you test a function, now you're gonna do that for the components, right? And yeah, here we are. We need to also define some other specific terminology like assertions, okay? The thing that you ideally like to be true, or should totally throw an error if that's not the case. So you got assertion, you got tests, you get test suite. So the test is just this, it's a function that makes your code to do things. So if everything go as expected, or with the assertion, all right, move on. otherwise throw an error, and the test suite is just is a fancy way to say a collections of tests, right? So we got now running your tests. So here we look at what are the tools that we need to actually do that. So for example, like vtest, which is part of the tool that we're gonna use. We're gonna use the React, TypeScript, vtest, site, playwright. Okay. And these particular tools needed to set up the infrastructure. And then we started to look at this, the getting started example. What are the how you can now is write your tests, and how now Vite is more descriptive than that. You can also put is the global variables if you're going to do a migration, okay, which make things way much more easy to work with. And this environment here that we are working either is Happy DOM or GS DOM. The sort of difference between them is that Happy DOM is a lightweight implementation of the GS DOM, where GS DOM is this spec compliant DOM API without the UI. All right, it is built on Node, and this is some of the things that we can do for that. So eat and test, there's no significant difference for that. Fails, you might want to sometime actually do that, as well as wrapping your asynchronous tests with promise, okay. And something that is very more specific to the server, that is run if and run or test run if, or in test skip if. So it's important because if you're gonna work with the backend, Node, that'll be a good fit for that, okay. And then you get now something like this. All right, so you got vtest. So vtest the UI. One of the great and compelling thing of using vtest is that it's not only that it's way much more faster because it's using ESBuild, which is a web bundler written in Go, which of course is way much more faster than bundlers written in JavaScript, and that now provides the ESM support, as well as you can easily migrate your tests from that. They provide you now out of the box is the testing the testing environment that you want to do, so you don't have to do that manually. So what it's doing is to integrating all of this, improve the error reporting, and provide you a flexible configuration. So when you run this, it's something interesting, especially the UI, because you can now visualize the tests, the model graph, the console. Sometimes you actually want to run a particular test in there, you want to console log things as a way to see what's going on, what to expect. So talking about expect, okay, expectations, okay, no pun intended. This is typically something only used while debugging. Expect and expect assertions. So with all of that theory, it is time for us to actually jump to the code right now, right? And here, especially to talk on the object tests, right? And this is quite interesting here before moving on to that, because after all, if you're going to make these applications maintainable, you need to know how that JavaScript works, and especially to verify, to assert those particularly, to check that everything works as expected. We need to actually understand is what is the referential transparency and referential object reference, okay, and or referential equality versus value equality. So referential equality, that to me is like, what? I don't know. Value equality, okay. Value equality, all right, you got is this. And when you talk about is referential equality, all right, is this. Verify the memory address of two objects to determine if they are the same instance, right? So one of them, look at it, is a value with primitive, and the other is like, you have now a drawer, if you can imagine a drawer. When you open up, okay, then you have now your socks in there, and they actually now have a label to that. It's like, hey, yeah, this is socks. So you are looking at that particular drawer, and then you know that you actually have the same drawer, the same box, the same sock, okay. Pretty much when you look now at your fridge, it's like, hey, I have this same meat. It's not this, is it's quite, the whole point of this is to understand that this referential equality is now looking if this tag, okay, actually refers to what it means, okay. We can talk about here in terms of money as a way to make a good analogy here. Look at that. Look at if this $100 actually $100 US dollar. Look at if this, right, has the same value that another one, that another instance. No, it's a terrible X. But in any case, referential equality. Referential equality. Okay, referential equality and value equality. Check if two or more objects have the same address in memory. Check if two or more objects have the same reference address in memory. Right? So far, so good. Nothing too fancy, right? And the other is value equality. So check if two or more variables have the same value. And here in the referential equality, okay, that's something interesting, because you can have now is shallow equality and deep equality. You can have now is shallow equality and deep equality. Right, okay, good. Shallow equality and deep equality. Okay. Shallow equality and deep equality. So shallow equality is just copying, okay, or is just check objects return the list of property of both objects and further check if property are equal. Exactly. A shallow equality is a type of equality that occur when the key value in both objects are equal. Shallow equality, check if all key and values exactly, but at first level. In this case, shallow copy. Is like this. So the shallow copy is which is something that when you build an object, is a shallow copy and a deep copy. But yeah, check if all the key values. Check if all the key values are the same, right? Check if all the key value in an object are the same with another object. So let's go. And the other is that it recursively do a shallow equality. Okay. Deep equality is a recursive shallow equality. A recursive shallow equality. Right, it's go to now all of these deep nested levels. That after all, nested object does technically speaking that you have a reference to another object. That's what happens, especially if you define inside of that object, inside of that property objects, its value is not a primitive, it's an object, so it's actually pointing to that. So what it's doing const is doesn't allow you to change that. What it's doing const is it won't allow you to change now the value of that. What does it mean is, no, I can't really. Okay, what does it mean is that if we create now icons here, objects, okay, you can say, hey, this is the name, Joe, really enough, man. Joe, last name Doe. Joe Doe or John. So John Doe. Okay. Followed by the age. It's like 33. So if you want to change the value of this object by reassigning it as another object, it's a no, you can't do that because const won't allow you to do that. However, you can now is change the reference or the value inside of this object. Say, hey, now is author, right? Is this one, sorry, because we are redeclaring that. Interesting. Really? Oh, no, unless you do something like this. Of course, because we are reassigning that. But you can is mutate that value. Right, so for example, like doing this. So you can change that. And when you check the object, so of course, it changes that. but you can reassign any value to that. That's what happens. So it tries to maintain the immutability of these objects. And especially if you have, for example, now deeply nested objects, which is now this deep copy. All right, let's say you have now, so details, and in these details you have is, of course you can dynamically add that to these objects, which is not going to change is the reference, it's just only change the value that you hold in that reference. Oh my god, it's pretty deep, bro. It's pretty deep. And here you got now is the name. You got now is the phone number. Phone number. Say some numbers here, right? Followed by zip code. You have now this, okay? So if you reassign this, is of course going to throw an error. What we can do is to create another object. Okay, and in this object, right, if we say, hey, I want you to now is change the details, right? Say phone number. One way to do that is by actually going directly to that particular property. All right. Okay. Or you can say, hey, this object one, which is this. So what if I want to do now a deep nested copy, right? I want to copy all of these elements. Okay, you can just go and try to do something like JSON stringify these objects, right? Right now there is no native way to actually do that. You can say is object one, okay, and then you string it, and then you parse that, okay, and then you say, hey, then I want you to now parse that using the parse as a way to create now is, right, is another object with another reference here, right? So doing this is say, hey, now I want you to compare it. So the object 2 is in terms of value the same, okay, but in terms of memory, location is different. Which means that, hey, object 1 is equal to object 2 is say no, false, because they are in different location. I got those organized in my drawer in different places. That's what happened. So, oh, this is how you can create now this. Unfortunately, this doesn't work for functions. Yeah, this doesn't work for function. That's what we have, for example, Lodash libraries or Lodash functionality that allow us to do that, which is kind of great, kind of cool. Yep. Kind of great, kind of cool. So. Yeah, so. Okay. Alright, so that was quite interesting. As a way to recap that, right? Shallow copy, deep copy, what is doing cons, what is doing let, and what actually is doing behind the scenes. And now This is something important because especially if you want to assert that these things work as expected, that you actually get that object as expected, now you need is to understand what is the difference between referential equality and value equality. How inside of the referential equality you have now shallow equality, which is taking all of the list of property and key and compare with another object if they are the same by value, and the other is deep equality. It's like saying, hey, we want now to, let me see if I got this exactly, and then deep equality. Exactly, this match recursively check equality in all fields rather than checking for the object identity. So you got now to equal and to be. So to be is shallow copy, right? Or in this case is okay. Check that a value is what you expect. It use object.is to check strict equality. Exactly. So here in this test, because it check for recursively, it say, hey, this is true. I'm assuming it's this, but this is not exactly. This test failed because it say, hey, I'm going to take a look now for the referential equality, and here I'm going to take a look now for the value equality. Makes sense. Makes sense. To equal, to be, you got it. Okay. Oh no. So to be and to equal, right? To be exactly. To be and to equal, it compares using object that is, okay, for equality reference, okay, and it compares it use is I think this is use. I think, let me see if that actually is what I'm assuming there. Exactly. Similarness and objects will pass with the hashtag equal. Exactly, because it's doing now is okay. To equal. So to equal compares shallow and deep equality. Okay, that's quite interesting. This is something that is low level here. It's similar to function, and after all, functions are objects. Functions are objects, and if you say to be, okay, functions reference. Function should to be strict equal if compared by reference. Exactly. If they compare by reference. If you're doing this, it's like, hey, if they compare by reference.
Unintentional pun. To say, like, I only care about two properties of this object. Like, whatever the other thing is, as long as it's some kind of string or literally anything, I literally only care about 2 or 3 properties, and make sure that this result, which might have 72 different properties, like, I only care about a few of these. And you can, like, use to equal to get a little bit more nuanced. So if you find yourself, like, accessing a bunch of properties and writing 42 different expectations, there might be a better way for you. And we'll talk about that in a second or two. But
and I get it. It's like, okay, so then it started to then it started to solve those particular.
let's jump in a little bit. What I want you to do at this point is take a look at exercise, where I've got, there is a list, and I think I have it in the notes in the repo, of like every different expectation. You can also go to the docs here, and you can see all of them. I picked the greatest hits. Right. These are the ones that, like, when I did like Command F in my own repo, had way more than the other ones. So we'll kind of just take them for a spin real quick and make sure that it works. So what you want to do is you'll notice we have these annotations here. It.to-do, it.skip are basically the same. It's a semantic meaning. Right? Skip is like, I don't want to run this test, right? Like a thing that I might choose to do when we get to some of the things that might happen later in this workshop is I might have a rule that says, hey, don't like use dots. Don't ship a dot skip to production, or I guess in your test suite. Don't merge it into main. The worst is like when you accidentally. I think older frameworks worse about this. Accidentally open up a PR with a dot only. And your test pass because only one of them was running. And so dot to do is more like, I will eventually write this test. Right. A lot of times I will write a bunch of dot to dos if I am feeling extra in the mood to do test-driven development. I will write all the different things that could possibly happen with dot-to-dos. I'll just knock them off one at a time. So in this case, this test suite passes. You know why it passes? Because it doesn't fail, right? Because these are all marked as to do, and the lack of failure is technically a passing. So what I want to inspire you to do is start turning off the dot-to-dos and see what happens. As you can see, like some of these you got to actually like write the implementation. That's why that expected has insertions is here. Otherwise, you would just take off the dot-to-do, and the test would pass. Victory mode. Write the implementation. That's why that expected has insertions is here. Otherwise, you would just take off the dot-to-do, and the test would pass. Victory mode, except you didn't do anything, right? So you can delete this line once you have a real expectation in there, right? Or you can keep it because it's not bothering anyone. But yeah, you want to start knocking these off and just try to do the implementation real quick, and then we'll talk about it together a little bit.
Okay, so let's get into this. Definitely, let's get into this. Create slides. You got it. Wait, what? Okay. Exercise test here. Okay, so you mentioned
happens. As you can see, like some of these you gotta actually like. What I want you to do at this point is take a look at exercise, where I've got. There is a list, and I think I have it in the notes in the repo, of like every different expectation. You can also go to the docs here, and you can see all of them. I picked the greatest hits.
Okay. This is a list of the greatest hit. Right. You got all of this. To be too close to. To be close to. What? To be close to. What in the F is this? To compare floating. We freaking those go here. The optional num digits argument limits the number of digits to check after the decimal point. Interesting. Look at this. To be close. Okay. To be instance of. Quite understandable. It's like, hey, is this actually have a reference? I think this must be from the prototype, right? To be instance, certify an actual value is an instance of the receive class. Okay. how do you check that behind the scenes that actually this is an object? This is the same instance, you know, to be instance of. Okay. Perplexity. How actually works in JavaScript. I don't know Java, none of that. The syntax to use is straightforward. Here, value is the object that you want to test, and class is the constructor function. And this constructor function, which is a reference or class, you expect the value. Okay, so this constructor function. Okay, so what is a constructor function? I know what it is, but exactly. This is a special type of function designed to create an initialize objects like this. This is a constructor function. So what you're doing is that, hey, do we have a reference to the constructor function? If they have the same reference, after all functions are objects, special type of object that you can call and add properties to that, add and change property and values, that makes a lot of sense behind the scenes. To be instance of. So let me check the function constructor of both of these objects. Okay, interesting. Okay, that's lovely. Okay, to be undefined. To contain, so to be undefined, right? Opposite to be defined, to be undefined, assert that value is equal to undefined. Okay, useful use case will be to check if a function hasn't returned anything. Okay, and they interesting. Useful use case will be to check if function return anything. And even though they actually tell you with v-test, it's like, what are the most common use case? To contain, assert if the actual value is in an array. Okay, to contain. You can also check whether a string is a substring of another string. Since vtest1 is your running test in a browser-like environment, this assertion also check if a class containing in a class list, but an element inside of another one. So for example, by doing to contain, which is check if the which assert if the actual value is in an array. Hey, is this value? Yeah. Hey, is this value here? Is this value here? Okay, if the actual value is in the array. Okay, that's interesting. To contain, check, but for in an array. Is this value is in an array? Is this value is in an array? Okay, interesting. Document query selector, that what is doing behind the scene is to return you is an element. Okay, to contain the element. Document query selector. Okay, is this value here? No, it's in this array. But it also can check for that to contain this, because after all it returned now is an element that you wanted to check if that actually exists in this wrapper to contain. That's interesting. That's very interesting. To throw. Okay. Expect the following type using the signatures. To throw. Wait, what? No, what is this? To throw or expect a chai API, Jest API. To throw. Oh, I think they changed that name? Yeah, I think they changed that. Oh, but to throw. Oh, but to throw doesn't exist right now? Interesting. No, to throw doesn't exist. Or they removed that. To throw, alias to throw. Oh, okay. To throw error. So if a function throw an error when it is called. Hey, could you execute this function? Is there something wrong with this function? Okay. Oh, okay, let's get into the exercise here. It to do should pass if two numbers will add up correctly in a language other than JavaScript. Describe. Okay. So it's to do. What it means to do. What it to do does. Test to do. An alias it to do. Use test to do to stop. Okay. No, but this is more like to. Okay, to stop this. To stop this. Okay, stop. To stop is what left is a thing. Okay, to stop here. Okay, to stop. To stop. Yeah. Okay, to stop this should pass if the two numbers will add correctly in another language like JavaScript. So here you are describing is a suite of tasks. Here person, Kanban board, and create person. So a spec has assertion. Verify that the person is an instance of a person. Oh, pretty simple. Okay. Yeah. Mm-hmm. Verify if a person is an instance of a person. So you say now is expect to be instance of but I think it's this. Expect that this object that we create, person, is an instance of the create person, the function constructor, right? However, I don't know how to use this assertion here. Let me actually see how the assertion is doing. Has assertion. What in the F doesn't mean that has assertion? So that has assertion, which is something that he briefly described, that hey, you should write your that this is typically something that I only use while debugging. Spec has assertion. Spec assertion 1. Okay, for debugging. Interesting. So let me now run this. Getting started here with the gray X. Where are you? See the great expectations. So if I, okay, there's a npm, you can say vtest binary here. Please use the binary here that I got here. Okay, it say, hey, everything pass. You know? This is exercise test. Yeah, this is exercise, but it's actually running all of this. Oh, okay. Yeah, because all of these are tests. So we, okay, because it skips that. If you say npm UI, so it's throwing a ridiculous port there to open up that. Here's the exercise test. Should create an instance of a person. And you say, hey, all model pass. Okay, that's why, what in the F? One is skip. So if you want to debug this, and yeah, we need to rerun this. Okay.
Let's find some things about JavaScript, shall we?
Yeah.
So we can do an npm test in here. I need to spell it correctly. You can see that like it runs all the tests. One like pro tip is if you just like wanted the one that's entitled like exercise, right?
I can pass now that. There's a way to say, hey, I just want you to run only this one. Right? So which is pretty much what we're gonna do. It's like, hey, I want this to now is run is the great expectation. No, it's on the exercise the tests, right? And please provide me the UI for that. Right? So this is 19 to-dos, which to me is quite interesting. Yeah, but it's like, what in the F is this? Okay.
Either npm test and I do exercise, and it'll just do like a partial file match. So now you can see anyone's word exercise in there will work, and then the ones that don't have that won't run. I could write exercise.ts, like whatever. It all happens. The other option is hit H, and then I can like do it by file name, so on and so forth. We'll look at some like other ways to like find just the test that you're looking for as well, but that's enough to get us started at this point. So let's mark this first one as active, and we'll hit save, and the test will run, and you can see that it breaks. Why does it break? Because JavaScript doesn't have the concept
about floating points, bro.
If anything, it's not a float. So as we all know, 0.2 plus 0.1 obviously equals 0.3, a bunch of zeros, and then a 4. Right? This is not, part of the like subtext for some of this is we all know what happens when your tests get flaky, right? You stop writing them, and then you turn them off, right? So step one is to get to the point where you're not turning your tests off, because it's hard to up the test coverage if you're constantly turning them off. And the answer's kind of hidden in this list up here. I'm gonna guess that it's to be close to.
Exactly. This is to be close to.
Close to. Cool. And that is like roughly looking for a certain amount of precision. If you hover over it, IntelliSense tells us that it also will take a certain number of digits in which you wish for it to be close to. So for instance, like I might choose like 2 if I was doing money, hypothetically. Right? In this case, since I don't really care. The one thing that I don't know if I noticed until just right now is if you look at the vi dot, the type is just assertion. Again, once again showing that everything we're doing by just, if you love just, that works too. And it'll do the thing. Cool. So we'll save this one. And looking up here, like if we need to see if something is an instance of a particular class, because we're looking for a person, all that really does is instantiate a new person class, or constructor rather, depending on. That's why I accidentally tell you how old I am. And so we can do
what it's doing is to check this function construction.
This person to be instance of.
To be instance of
person.
The person. Exactly.
Right. Anything that has that as a constructor in the prototype chain will pass in that case as well.
But again, the idea of this is like
person.
You turned that out to be okay. Okay, yeah, it's chill. Whatever. Exactly. I want you to run is only this. All right. Without the UI. Exactly. 2 hours skip. And then I say, hey, you know what? Oh crap. How do I uncomment things? Control Q, control, okay. Control Q and U. No, that flag you do. Command Q and U. Well, that's right. Command K and U. What are you doing? That doesn't work. What do you think you're doing? I'm here. Okay, it's command U. Okay, command K. Command K, command comment. Command K, command uncomment. Okay. Good. So we got this. Hit F4, throw an error. Let's go to learn something here about this. So if you're doing some applications, money applications, you say to be close to that. Now the test pass, right? And here you're gonna change to this. All right, and it say, hey, it says verify the version. The instance assertion needs a constructor, but function was given. But function was given. Yeah, I'm providing is a function constructor. Exactly. Okay, I'm providing is a function constructor. So yeah, this actually is a person, but the person. That's quite interesting. Oh, but I'm doing it for debugging. Expect has assertion. Expect has assertion. Verify that board status contains backlog. But since I don't know what Canva is, because I can't have access to that. If I close this and open again, still say, hey, I couldn't find a corresponding type for this. Okay, good.
Done. Right. Anything that has that as a constructor in the prototype chain will pass in that case as well.
Anything that have a constructor in the prototype chains.
This will be somewhat useful to us, like momentarily. Great. And then, we have the subscribe block. What does the subscribe block do? It basically, if you looked in the UI before, it organizes your test. So like it indents them and puts them all together. You can skip a whole bunch, or you can do a whole bunch, or you can only a whole bunch. It's just a way of organizing your test. Do you need to do a subscribe block? You do not. If you just want to write it or test at the top level, what Jess and my test do is they just wrap that all in a subscribe. Right? A file is effectively wrapped in a suite, but then you can you can test these as much as you want. You shouldn't, but you could. And they will share any kind of hooks that we'll see in a little bit as well. Cool. And so in this case, like we can see, we can see if it has. In this case, we want to see it should include a backlog in one of its many statuses.
Check for the
right. And so in this case, we can expect board dot
to contain the element data.
Right. This is effectively doing backlog.
They're not to include.
In this case, it is to contain, but I have to board the statuses. Let's find out together. No, it's to contain, which I will never, at this point in my life, remember strings have a dot contain and arrays have a dot include, or vice versa. So strings have a includes and arrays have a contains. So
exactly. It's
I don't know if it's a contain at all.
That's includes. I don't know. It's the test assertion is to contain. We can also do the opposite of that, which is we can assert that it does not have.
Because it's going to check for arrays. It's going to check if this array elements, which is something that I don't know. What is this? It's your weird data that you have, that the shape of your data you have, that by running is the aspect of the board statuses, because I don't know what's the data is inside of that. That's what happened. I can't have access to that data, so I'm just trusting in that I actually have that. So to contain, what it's gonna do is to actually see, right? If that object used when you want to check that is an item in a list. Exactly. Hey, this item is in a list. The backlog. Right? Hey, this item is in a list. Okay. Of course, say, hey, to do it, skip that. Yeah, it is. Board statuses is to contain. Should not include bogus in board status. And that is well, pretty much using the so you remove this and say, hey, expect that this object called board.statuses, okay, to not contain okay, I want you or to throw an error. To contain To contain, to not contain. Interesting. Expect to fail, right? Or you can say it's like, hey, fails. Okay. I want to check if this test fail, but if this actually contain is the word or the elements on this array called bogus. So when you save, of course, it's actually do this should not contain the bogus in status.
Right. Or not to contain.
No, that doesn't exist. Interesting.
Cool. And as you can see, we're kind of passing as we go through, but I did need to unblock that one. Sweet.
You can also that it fails. Okay, when it fails, that is to not contain. Okay. To contain. There's another way. Okay, they actually passed that.
You'll see like the number that says to do here, right? Like that's a great way to get a sanity check on whether or not you're actually whittling down the list. That is different than like, the being skipped per se, only in a nomenclature way, right? Like it's the same thing, but it's a way for you to keep track. Cool. And now we get a little more detailed here, which is we should be able to add something, add a status to the board, and then say this there as well. And so we could say something like,
should we include an add status?
We'll get rid of this for a second. And we'll say board dot add status, and we'll say, what are we looking for? Verifying. Whatever. You pick up whatever you want. And then we can expect that if we call that status, then it should be in there.
Board status to contain.
And you'll see that one of the things that I'm doing here, if you don't spell right, because you're talking and coding at the same time, you have issues as well.
Yeah,
it's kind of a common pattern test, which is like kind of a setup, the exercise, and then we can kind of verify, right? So you kind of break it into these three phases as well. The exercise, and then we can kind of verify, right? So you kind of break it into these. One of the things that I'm doing here, if you don't spell right, because you're talking and coding at the same time, you have issues as well. It's kind of a common pattern for tests, which is like kind of a setup, the exercise, and then we can kind of verify, right? So you kind of break it into these three phases as well. Can you?
Most of the time when you are doing this, you should include add a status. So when you do this, you are essentially doing is like board, because I couldn't have access to that, board add a status. Okay, add status. Let's say done, right? Add a status in plural, exactly board, and then you now expect here this by saying, hey, I want you to expect that this particular object on this statuses to contain in that list the DOM property. And because I don't want to actually make this a to-do, I actually want to test if this it work as expected. So as you can see here, all right, for example, in this particular example, right? Just an example. Okay, so for this particular example, it should include an add status, import status using this, right? We have the code. What if you, yeah. Because it's hard to do that. So this is the solution, like below. In the image below, which is here, you can see the common pattern in the repetitive things that we need to do. The common pattern when writing your test. You get the setup, the exercise, and the assertion or the expectation. And the assertion, right? Assertion.
You use like a before each to like create this board. You can. I choose not to because you know what I don't need in my tests? Things to be abstracted and clever. Like I just want to see what's going on when my test is failing. I'm not in the mood to like scroll up and look to see where that thing was populated. And like you think everything's going to reuse the same object, and then you find out very quickly that no, you actually need different ones in some cases. So, cool. And so as well. Can you use like a before each to like create this board? You can. I choose not to because you know what I don't need in my tests? Things to be abstracted and clever. Like I just want to see what's going on when my test is failing. I'm not in the mood to like scroll up and look to see where that thing was populated. And like you think everything's going to reuse the same object, and then you find out very quickly that no, you actually need different ones in some cases. So, cool. And so we go ahead and we can also remove one as well. And we do, you know, this will be the same basic idea in this case, right? So we say board, remove status, and we'll say
exactly, because I don't know what is a shape
backlog, and then we should expect. Now this was an interesting one because I might choose to do this one in 2 steps, right? Because like if I remove one that's not there, it could still pass, right? Like if I mess this up. So this one I might choose to like write 2 sets of expectation, one that's there and then that's not. Mark.
If add status was an async call to the server, would the test look similar to this?
2 sets of expectation, one that's there and then that's not. Mark.
If add status was an async call to the server, would the test look similar to this?
I'm going to answer that question now, and we'll talk about this, and this will kind of help us skip the section later. So the question was, if add status was asynchronous, what would happen, right? And it all depends, right? In this particular test, it would fail because we run a function from top to bottom in JavaScript before we check the event loop. So here we would add it, and then we would insist that it was in there, and it wouldn't be in there yet, right? That said, like if, for instance, where this gets a little bit more problematic would be this test here, right? Which is, it's a lot harder, like, if it wasn't in there, you get to some weird edge cases, right? Because this wouldn't have happened yet. If things do return a promise, which is very easy in the modern era to simulate, boom, now it's an asynchronous function that returns promise. We remove status, and we say not to contain backlog. Cool, and then so this one passes. Did I save that file? basic move statuses. Because it's modifying the object. If I was waiting for a return value, this wouldn't happen. But like, because it's a class, it just happens to work. But you know, you can see a world where it's like, if this was a function with return value, we wouldn't have it yet. And this is where it can become somewhat tricky. If you need to deal with the fact that you need the actual function to get called and fully resolved first, that is relatively straightforward. You can just make it an async function and await it, right? And so like, it depends. The like problem here is that like, if I like misspelled like this one, like it also still passes, even though it shouldn't. Right? And this is where like you might choose to like make a test fail to make sure you're getting what you want if you ever have any suspicion, particularly when you're dealing with asynchronous things. Because like, again, the absence of a failure is technically passing, right? And this can bite you in fun and unexpected ways.
Badly.
And then it doesn't be backlog. That was never there to begin.
Yeah. And so like, it's passing because it works. You know what I mean? Like, it's true. And this is why sometimes you would want to either make your test fail, or say to contain or something along those lines. At least get the feedback loop that you're not like...
To expect, and that's the same problem.
Yeah, I might expect that it's in there first, and then expect that it's not, you know? And there are other ways you can structure this as well, right? Like, here I made a... Like, this would catch it, right? Because it's not in there. However, still subtly broken, but passing, right? And my recommendation for how to solve that would be to just take yourself out of the equation as much as you can, and just store it in a variable, which is like, cool, we have a status, because spelling a variable name wrong will blow up in your face. We'll expect that it's in there, remove it, and then expect that that same one is not in there. And this is going to make you a lot happier as a person, because now your test will not accidentally pass because of some reason in this case.
It's all the same runtime, so we can assume that board static, like you'd almost want to set that more higher globally if you're going to use it for multiple tests in the same suite.
Maybe, right? Like, could I like do it before each, or like even if it was like, you know, and then reset it? Yes, but then like, and we'll see how to do that. But then like, it's tricky because now I'm not very smart, and if I don't see it in my very large font editor right now, like it becomes tricky as I have to like scroll up to verify a thing is what I want to have. Like all of, like for a lot of times, like the whole do not repeat yourself kind of thing, I think is true for the actual implementation of writing software. Sometimes for my tests, I would rather repeat myself and have it be incredibly explicit, particularly when I'm like refactoring code and I didn't expect a test to break. My patience is way lower than if I'm like writing a feature for the very first time, you know? So in those cases, a lot of times I will choose to repeat myself, because then all of a sudden you set it one, but you need this one to actually be a little bit different, and it just gets confusing. But then there are some times where it's like, if it is a lot of work each time, then yeah, you do it before each or something along those lines. It is kind of, you know, I defer to your judgment in this case.
Mm-hmm. That is quite interesting what he mentioned that. So when writing your code, keep it simple as possible and dry, right? But when writing, do things dirty and do things dirty and fast. But when writing tests, do things. Oh my god, yeah, it is. But when writing tests, do things fast. But when writing tests, repetitions is good to maintain or to keep everything at a glance. Holy F. That'll be all for this video. Take care. Bye bye.